This is Bandit, a computer I've been working on for some time now. The idea is very simple: 32 keys, a vertical form factor LCD, audio, video, and GPIO connectors. It runs on batteries too. I'm particularly fond of the double incline, the screen at a 22-degree angle versus the typing surface at a 15-degree angle. This allows for easy access to the touchscreen. I wanted simplicity and also reliability, so of course I have it running ColorForth, Baremetal. So, why don't we take a look at it in action? Let's have a quick introduction. The first thing you'll notice when looking at the machine is the strange quasi-QWERTY keyboard layout. It omits things such as symbols, numbers, and even the spacebar. This is intentional to keep things compact. Instead, we used a corded approach. This allows to keep things tidy, but also to fit all the keyboard state in a single 32-bit number. Then you'll notice the colored words. This is not syntax highlighting, but instead is part of the ColorForth language. Forth by itself is very simple. You teach the computer how to do things by creating definitions inside a dictionary. You can then use those newly defined entries, also called words, to create further ones, and so on. This way of programming allows you to have user-defined syntaxes. However, by encoding a few compiler behaviors, such as treat this as a number, or treat this as a new definition, or inline this piece of code, and that's where ColorForth enters the game. By using color to encode these specific behaviors, things get simplified even further, and your mental gears shift. The best analogy I found is that it feels like playing Tetris, which is not far from reality. You find yourself rearranging code, getting rid of unnecessary lines. It's a very zen process. Now, let me give you an example of how little limitation we have in the language. Here I have the block explorer. I can see the entire memory of the chip and use it as I please. As it happens, I made a small mistake when writing the compiler. Instead of hiding the compiler before the source code space, I put the compiler straight in the middle. Turns out, if you write memory into these two little blocks, you'll freeze the computer. We have complete control over the system. Now let's go into another peculiar choice I've made for the machine. The screen at 320 by 480 pixels is in a vertical aspect ratio. This decision came in part to accommodate all the keys, but also being SPI driven, it allows one to have two 320 by 240 virtual screens. Currently, I'm using the top half to display my code as it refreshes faster, and the bottom half as a reference screen or just to hold data in place. For example, here I'm running the same program twice, once for each half. And here I'm storing the rendered screen at the bottom. Another obvious use for the keyboard is as a sampler, in the same vein as the old school Akai MPCs. We can use the 32 megabytes of DRAM to store and retrieve music samples in real time. Currently, I have it sampling about 24 voices, each with their own pitch, attack, release, and volume. I can even record sequences and play them back, although currently the quality is very low at 16 kHz per sample in mono audio. Another obvious use for the machine is to have it be a typewriter of sorts. Even though the keyboard layout is optimized for coding, especially ColorForth coding, you can still comfortably type in it since it's just very compact. And since it operates on batteries, you can also carry it around. So if I run this by pressing this and this, a left P, it will compile and give me a caret and some encoded data here on the left. So I can just type something like hello world. And I will get my text. I can also press return. And as you can see, the text moves up, leaving you always with the text you are typing in the middle. I can also sort of delete, but it's not very useful at the time. This is all for now. Thank you for watching. If you'd like to get one and don't mind waiting a little bit, then by all means, dscf.co.uk/bandit. I'll start shipping as soon as I can. As always, this wouldn't be possible without the support of my Patreons. Thank you all for your patience in this very slow project, but we're getting there. So, I'll see you next time. Take care.